Hello everyone, welcome to the lecture series of Engineering Mathematics 1. This is our 8th lecture on partial differentiation. Here today in this lecture we are going to see some more examples on change of independent variable. Okay, so let's see. This is the first example. Actually in previous lecture we have solved some examples on this. Okay, so in this video this is our first example on the topic. Let's solve this. What is the given part? See here, z is equal to f of xy and u is equal to lx plus my, v is equal to ly minus mx. Then we have to prove here dou to z upon dou x plus dou to z upon dou y square is equal to L square plus m square in bracket dou to z upon dou x plus dou to z upon dou y. Okay, so here again we have to find double derivative of a function. Okay, but if you are finding here double derivative by using a chain rule, then we just have to use the differential operator value. Okay, that we have solved in our previous lecture, a last example of the same kind. Okay, if you not watched that video, first watch the video completely and then come to this lecture. Okay, see here, first of all, always we have to write down your given part. What is the given part? Z is equal to f of xy and u is equal to lx plus my and v is equal to ly minus mx. Okay, so from this we can write down the dependency. Z is depending on xy and xy is depending on, we can say, uv, right? We have a value of u and v in terms of xy. Okay, so we have to convert these values of u and v into u and v. Using this value of u and v, we have to find the values of xy. Okay, but if we solve this example by using this dependency, z is depending on uv and uv is depending on xy, this will also do. Why? Because we don't have a function z in terms of xy. Okay, so here I can use this dependency and I can write chain rule for this. So if I want to find z with respect to x, I can write here z with respect to x is equal to z with respect to u, then u with respect to x. So here write down z with respect to u, u with respect to x plus then z with respect to v and v with respect to x. Z with respect to v, v with respect to x. Similarly, I can write the derivative of z with respect to y by using a same chain rule. Z with respect to y, that I can write z with respect to u, then u with respect to y. So here it is z with respect to u, then u with respect to y plus z with respect to v and then v with respect to y. Okay, so here we got the chain rule. Let's say this is equation 1, this is equation 2. Okay, now to find all these two values of z with respect to x and y, I have to find all these partial derivatives, right? But we don't have a z in terms of xy. So wherever the derivatives of z, that will be as it is. Okay, so we have to differentiate u and v now with respect to x and y. So first of all, we are going to use a first value for u. U is equal to lx plus my. Okay, differentiate u with respect to x. So what I can write? U with respect to x is equal to with respect to x we are differentiating, so y is constant. What is the derivative for u then with respect to x? It is only L. Okay. And what is the derivative of u with respect to y then? Yes. While differentiating with respect to y, we have to keep x constant. So what is the derivative then? It is m. Okay. Now next, same we have to find for v. What is the value for v given to us? It is Ly minus mx. Now differentiate v with respect to x. So what is the derivative of v with respect to x? Yes, you can see keeping y constant, it is minus m. Then v with respect to y, keeping x constant, derivative of v with respect to y, it is L. Okay, putting all these derivatives here in equation 1 and equation 2. So I can write here from equation 1, dou z by dou x is equal to, put the value for this, what I will get? Z with respect to u as it is, and derivative of u with respect to x that we have find, it is L, plus z with respect to v as it is, and derivative of v with respect to x that we have find here, minus m. Okay, so we can write this z with respect to x is equal to L into z with respect to u minus m into z with respect to v. So from these also I can write a differential operator dou by dou x. What is it? Yes, just we have to remove here z from this derivative. Okay, dou by dou v, right? Now differentiate dou z by dou x again with respect to x, means we have to find its double derivative because it is required. See that we have to prove. So if I differentiate this term again with respect to x, that will give me dou 2z upon dou x square, that is equal to dou by dou x of dou z by dou x, right? But what is the value for dou by dou x here? Yes, tell me. Yes, this we have find here. So I can write here L into dou by dou u minus m into dou by dou v. Then dou z by dou x. This also I have find here. What is it? L into dou z by dou u minus m into dou z by dou v. Okay. Now we have to solve this product here simply, and that will give us dou 2z upon dou x square. So here if I solve the product of these two brackets, see what I get. I'll get here L square dou 2z, not u, just a minute. Dou 2z upon dou u square, right? Then minus 2lm dou 2z upon dou u dou v plus m square dou 2z upon dou v square. Okay, so I got here value for dou 2z upon dou x square. Similarly, now I have to find the value for dou 2z upon dou y square. Same concept we have to use. So we have to use here now equation 2. So I can write here from equation 2 dou z upon dou y is equals to, right? See here. Here it is our dou z upon dou y, right? We have to put the values of u with respect to y and v with respect to y. So that will give me z with respect to u into, what is u with respect to y, it is m. So I can write here it is m plus z with respect to v and v with respect to y. What is the value for v with respect to y? It is L. So I can write here L only. Okay. So this gives me the value for z with respect to y is equal to m into dou z by dou u plus L into dou z by dou v. Right. And from this I can write a value for differential operator dou by dou y m into dou by dou u plus L into dou by dou v. Now to find dou to z upon dou y square, differentiate dou z by dou y again with respect to y. So that will give me double derivative of z with respect to y, that I can write dou by dou y of dou z by dou y. Okay, that is equal to m into dou by dou u plus L into dou by dou v. Okay, and what is the value for dou z by dou y? It is dou z by dou u. Okay, just I have to write here m into dou z by dou u plus L into dou z by dou v. Right? Solving the product of these two brackets, that will give me m square dou to z upon dou u square plus 2ml dou to z upon dou u dou v plus L square dou to z upon dou v square. Okay. Now here I got the value for dou to z upon dou y square. Okay. So using these two values of dou z with respect to x and y, I can now show the proof here that we have to show. So I can now consider, see, on right hand side. Yes, what I can write here, just a minute, there is a little correction, I will tell you it after the example. So if I take the addition, now dou to z upon dou x square plus dou to z upon dou y square. Okay, that is our actually left hand side. Okay, here definitely it should be u and this should be v, not x and y. That is a correction. Okay, so if I do the addition here, see what I get. We are adding, suppose, this equation A and this equation B. So you can see dou to z upon dou u square. Here also dou to z upon dou u square. But when we add, it is L square and here it is m square. So when we do the addition, we will get here term L square plus m square. Okay, dou to z upon dou u square. Okay, then now see this term, it is positive here and here it is negative. So when we add, this term will cancel. And similarly for the last term, when we add, what we get, see here, that is plus L square plus m square dou to z upon dou v square, right? And here finding this L square plus m square common, what is remaining? Yes, dou to z upon dou u square plus dou to z upon dou v square. That is our required proof. You can see here, this is our left hand side and this is our right hand side. So we can say here, hence proved. Okay. So this is how we are going to solve the example. If in a chain rule, you have to find dou to z, means double derivative. Okay. Double derivative of function. Now next example is, u is equal to f of x upon y, y upon z, z upon x. This is given to you. Okay, and we have to show this first order relation is equal to 0. Okay, so what we are going to do here, see, let r is equal to x upon y, s is equal to y upon z, and t is equal to z upon x. So from this I can write dependency. U is depending on, see what happens here, u is equal to f of, if I put the substitutions, all these r, s, t. We can say u is a function of now r, s, t, and r, s, t are functions of, you can see here, that is the substitution we have taken, x, y, z. Okay, so here what happens, see, I can write a chain rule. U with respect to x is equal to u with respect to r, then r with respect to x, plus u with respect to s, s with respect to x, plus u with respect to, yes, t, and then t with respect to x. Okay, so this is how we can find by using a chain rule derivative of u with respect to x. Now similarly we have to find the derivative of u with respect to y using a chain rule. So see, what is it? U with respect to r, then r with respect to y, plus u with respect to s, s with respect to y, plus u with respect to t, and t with respect to y. Similarly, the last derivative we can write here, that is u with respect to z. So it is u with respect to r, r with respect to, just a minute, it is x. Okay, that was right here. Y, here actually it is z plus u with respect to s, then s with respect to z, plus u with respect to t, and t with respect to z. Okay, so these are the chain rules that we got here. Here your function is of 3 variable, so we got a chain rule for 3 times. Okay, now what is the next? Yes, definitely we have to find all these partial derivatives, but u is a function of r, s, t, we are saying, means we don't have a value of u, right? So what are the derivatives of u there? That will be as it is. So we have to find here derivative of r, derivative of s, derivative of t. So first of all, let's find, let's use here value of r. It is x upon y. So finding a derivative of r first. So what are the derivatives of r? See here, r with respect to x, 1 upon y is constant. So derivative with respect to x, it is only 1 upon y. Now r with respect to y, keeping here now x constant, so that will be minus x upon y square. Okay, then r with respect to z. So we can see there is no z, so complete term will be constant, and so its derivative is 0. Similarly now, what we have, s is equal to y upon z. So find the derivative of s. So derivative of s with respect to x, there is no x, so the derivative will be 0. Then s with respect to y, it is 1 by z. s with respect to z, it is minus y upon z square, right? And the last value is what? T. T is equals to z upon x. So if I differentiate here t with respect to x, what is its derivative? See, yes, it is minus z upon x square. Then we have to find the derivative of t with respect to y. What is the derivative then? Yes, it is 0 because there is no term for y. Then derivative of t with respect to z, that is our last derivative. X is constant, so we can write here only 1 upon x. Okay, so these are all derivatives. Now using these all derivatives here in equation 1, equation 2, equation 3, what we can find, see here, I can write from equation 1, u with respect to x is equal to, see what I can write, u with respect to r, u with respect to s, u with respect to t. So here you can see all these derivatives will remain as it is because u is only saying a function of r s t, right? And here r with respect to x, s with respect to x and t with respect to x. These all derivatives we have to put that we are finding here. Okay, तो यहाँ पे देखिए यहाँ पे वैल्यूज क्या हो जाएगी फिर, then u with respect to r into r with respect to x. What is r with respect to x? It is 1 upon y. So let's use this value here. Then plus second one, dou u by dou s means u with respect to s, s with respect to x. What is s with respect to x? It is 0. So we don't have to write that value. And last one, u with respect to t and t with respect to x. So what is t with respect to x? Minus z upon x square, right? So let's write here minus z upon x square into dou u by dou t. Okay. Now see, this is u with respect to x means ux that we can write. But here in proof, ux is multiplied by x. So let's multiply here by x. Multiply by x. What we get here? X into, I can write this dou u by dou x ux. Okay. So x into ux is equal to, multiply here on right hand side by x. It will be x upon y dou u by dou r. Now this is minus. If I multiply here by x, 1x get cancelled. So it is z upon x u with respect to t. Okay. So I hope you all understand. Now next, from equation 2, what I get? I'll get here u with respect to y. Okay. Let's use equation 2 here. See, this is your equation 2. So u with respect to r and r with respect to y. What is r with respect to y here? This minus x upon y square. So let's put this value, u with respect to r and r with respect to r minus x upon, yes, this is y square. Okay, plus now second value, u with respect to s, s with respect to y. What is s with respect to y? 1 upon z. So we can write here u with respect to s and s with respect to y, that is 1 upon z. Okay. Now here I have to multiply this. Just a minute. I have to multiply this. See, I haven't written here third term. Let me explain you first that. Because t with respect to y is 0 here. So that term will be 0. That's why we are not writing it. Okay. But now here, this second term, that is uy, means derivative of u with respect to y is multiplied by y. So we have to multiply this by y. So multiply by y here. What we get, see? Yes, it is y into uy is equal to minus x upon y, u with respect to r plus, yes, if we multiply by y, it is y upon z u with respect to s. Okay. Now the last value we have to find, that is z into uz. Okay. So we have to use for that third equation. So we can write from equation 3, that will give me the value of u with respect to z. Okay. So let's see here what happens here. If I use this equation, r with respect to z is what? 0. Means your first term now going to be 0. So you will get only these two terms. Okay. What is s with respect to z? Yes. Minus y upon z square. So I can write here u with respect to s with respect to z. It is what? We have seen minus y upon z square. So let's write here minus y upon z square plus then u with respect to t, right? See here, u with respect to t and t with respect to z. What is t with respect to z? It is 1 upon x. So I can write here 1 upon x. Okay. But now here, this u with respect to z is multiplied by z here. So we have to multiply this by z, right? So multiply by z, what we get? Z uz is equals to minus y upon z u with respect to s plus z upon x u with respect to t. Okay. Now consider here left hand side. What is left hand side of the proof? This one. So I can write here x into ux plus y into uy plus z into uz equal to, means I have to do the addition of these three equations. Okay. So if I do here addition of these three equations, you can observe this is a term for u with respect to r, and here also this is a term for u with respect to r. Both are same, but their signs are opposite. So when we add this, the terms are going to cancel. Okay. Now here you can see u with respect to t. Okay. And here also u with respect to t. So when we add, they are having opposite sign, but they are same. Again they are going to cancel, right? And the remaining is u with respect to s. Okay. These and these term both are same but having opposite sign. So when we do addition, this also will cancel. So what we get here? We get here answer 0 after doing the addition of these three equations. And that is our required right hand side. Hence proved. Okay. So this is how we are going to solve the example. I hope you all understood the example. Now the next example is given to us here that we have to solve. Here we are given x is equal to u plus v plus w. Y is equal to ub plus vw plus uw. And z is equals to uvw, right? So from this, see here, in proof you are having derivative of phi with respect to xyz and derivative of phi with respect to uvw. So I can write here dependency. Phi is depending on maybe xyz, we can directly write, or uvw, because we don't have a function of phi in terms of xyz and uvw. Okay, but we are having a values of xyz in terms of uvw. Means your xyz is depending on uvw, right? So what I am going to write here, suppose your phi is depending on xyz and xyz is depending on uvw. So here I can derive the chain rule now. Now I have to find phi with respect to u. So what should be the chain rule? Yes, it is phi with respect to x, then x with respect to u plus phi with respect to y y with respect to u plus phi with respect to z, z with respect to u. Now see here, all of you understood how we are going to solve the example. So I'm now directly going to put the values here. Okay, so hope you understand. Now see, I don't have a phi function in terms of xyz or uvw. So whatever the derivatives of phi, that will be remain constant. So we have to keep it as it is, phi with respect to x. Okay, here x with respect to u. You are having a value for x. What is x with respect to u from this? Yes, it is 1. Plus, then phi with respect to y and y with respect to u. Here it is your y. If I differentiate this with respect to u, what is the value? See, derivative of this ub, it is v, and derivative of this uw, it is w. So I can write here v plus w. Okay, and plus then phi with respect to z. What I can write? Here it is your z. What is the derivative? vw. Okay, but this derivative of phi with respect to u, see here on right hand side it is multiplied by u. So what we have to write? Multiply by u. So what we get here? U into dou phi upon dou u, that is equal to u into phi with respect to x plus u into v plus w phi with respect to y plus u vw phi with respect to z, right? So that I can write u phi with respect to x plus multiply ub plus uw phi with respect to y plus uvw phi with respect to z. Okay, let's say this is our equation 1. Now similarly we are going to find phi with respect to y. Use the chain rule from here. What it will be? Phi with respect to y, that is equal to so here I can write the chain rule, phi with respect to x, then just a minute, phi with respect to u, then u with respect to y plus phi with respect to y. So there is a correction actually. See, from this phi with respect to x and x with respect to v, that should be right. So here it is phi with respect to x and x with respect to v. And here also we have to do the correction. This is not y. This is v. Okay. Then plus here y with respect to v plus phi with respect to z and then z with respect to v. Okay. Now we are putting the values of these derivatives. Phi with respect to x as it is because we don't have a function, and x with respect to v. We can differentiate this with respect to v. What is the value? 1 plus phi with respect to y and y with respect to v. Differentiate this y with respect to v. What is the derivative? See, you can write here u plus w. Okay. Then plus phi with respect to z and z with respect to v. This is a z. Differentiate with respect to v. It is uw. Okay. And now this derivative of phi with respect to v, that we have to multiply here by v. So if we multiply here by v, that will give you v into dou phi by dou v is equals to, okay, so I can write here phi with respect to x plus, here we are going to multiply this by v. Okay, then here we have to multiply by v So I can write here now directly VU plus VW. Okay. Derivative is phi with respect to y plus here multiply by v, so it will be UVW. Then phi with respect to z. Let's say this is our equation 2. Okay. Similarly, now the third derivative we have to find, that is phi with respect to w. Okay. So from this dependency we can write the chain rule for that. What is it? Yes, phi with respect to x, then x with respect to w plus phi with respect to y, y with respect to w plus phi with respect to z, z with respect to w. Okay. So we are putting the values of derivative. So what is it? Phi with respect to x, x with respect to w. Here it is your x. What is the derivative? Yes, it is 1 plus phi with respect to y, and then y with respect to w. Here it is your y. Differentiate this y with respect to w. Definitely it is v plus u. Okay. And plus phi with respect to z. Differentiate this z with respect to w now. That is uv. Okay. And now here if you see your phi with respect to w, it is multiplied by w. So we have to multiply here this derivative by w. Okay. So multiply on both sides. So what you get here, see, if I multiply this by w, w dou phi upon dou x plus here u plus v. So I can write u plus v dou phi upon dou y plus UVW dou phi upon dou z. Here we are multiplying by w, so there will come w in multiplication. Okay. Now see here what happens. Let's see, this is our equation 3. So I can solve now right hand side because I have all these derivatives. So consider here right hand side. What is it? It is a addition of all the derivatives of phi with respect to u, v and w, right? So let's do your addition of all the derivatives. We have already find the values, right? Just we have to use, see, this is your equation 1, this is your equation 2 and this is your equation 3. If I do the addition here, what happens? See, phi with respect to x, then here also phi with respect to x and here also phi with respect to x. This derivative is same but their coefficient is different. Here it is u, here it is v, here it is w. So while doing addition, I can find here phi with respect to x common and this will give me u plus v plus w phi with respect to x. Okay. Plus. Now see, for the second term, phi with respect to y, phi with respect to y and phi with respect to y. So finding this common, we have to do the addition of its coefficients. And you can check here. If we do the addition of these coefficients, what I get? uv and here also, yes, uv. 2 times the terms are coming. So simply I just can write here 2uv plus 2vw plus 2uw. If you solve this, you will get the same answer. Okay. Phi with respect to y plus. Now the next one is what? Last term. Phi with respect to z, phi with respect to z, phi with respect to z. So all these 3 terms are same. So I can simply write the addition here. 3uvw y with respect to z. Okay. Now see, u plus v plus w phi with respect to x. Finding here 2 common, uv plus vw plus uw phi with respect to y plus 3uvw y with respect to z. Okay. But you can see here, what is u plus v plus w? It is x. ub plus vw plus uw, it is y, and ubw, it is z. So simply replace your values. I can write this is x dou phi by dou x, okay, plus 2y dou phi by dou y plus 3z dou phi by dou z, which is our required left hand side, and here we can say hence root. So now I hope you all understood how we can solve the examples based on this change of independent variable. So thank you all for watching this video. I hope you all understood your second unit, partial differentiation. This is the last video on the unit. Thank you all.